Welcome back to the lecture. In the previous lecture, we have seen that what is Fourier transform DFT. In this lecture, we will continue and see how we can transform a time domain signal into frequency domain signal. For the transformation of time domain signal into frequency domain signal, we have the formula x of k is equal to summation 0 to n minus 1 x of n e power minus j 2 pi n k over n. So what is k here? K here is the frequency domain samples, number of samples in frequency domain, n is the number of samples in time domain. What is capital K here? Capital K belongs to these two components. It can be either greater or equal to number of samples in time domain, n samples. So let me tell you first what this exponential represents. Suppose we have n is equal to 4. As you can see, x of n, here is the example. So if we want to see how this exponential behave, we have the formula of Euler identity, which tells us that e power j theta is equal to cos theta plus j sin theta. Now, if we want to find the value of j, e at 0 degree, put this into this one. We know that cos 0 is equal to 1 and sin 0 0. Now if we put the value of pi by 2 into this exponential, we will get cos pi by 2 plus j sin pi by 2, which will be equal to j. Similarly, if I put pi in this formula, cos pi plus j sin pi, it will turn out to be minus 1. And at 270, it will become minus a. So if we want to plot this becomes a complete circle. If we have 4 samples, this circle can be divided into 4 segments, 1, 2, 3, 4. So if we have n is equal to 6, we can divide it into 6 equal components. If we have n is equal to 8, we can divide it into 8 segments and so on. So now we want to see how this signal in time domain can be converted into frequency domain. First of all, x of 0. What is x of 0? N is equal to 0. Small n is equal to n minus 1. So what is n here? 4. 4 minus 1 is equal to 3. So put this x of 0 e to power minus j 2 pi 0 into 0 divided by what is n? 4. So if we solve this summation, what will be the answer? What you have to do is to just open this summation. As you can see that there is 0. So this exponential will simplify to e power 0. So put the value of n here. Plus x of 1 e power 0 plus x of 2 exponential power 0 plus x sub 3. Now what is x of 0? 1 into 1 plus 2 into 1 plus x of 2 is 3. Here is x of 0, x of 1, x of 2, x of 3. So it turns out to be 4. Similarly, if I want to find the value of x of 1 when k is equal to 1, for 4 samples we have the frequency domain samples from 0 to 3. K should be equal to 1, 2, 3, 4. 0, 1, 2, 3. For n, capital N is equal to 4. So if we want to find x of 1 in frequency domain, it will be like this. Put the value of k. Now first one is 0, second x of 1 minus 1 into 1 by 4 plus x of 2 into e power minus j2 n is equal to 2 1 over 4 plus x of 3 e power minus j2 by into 3 and 1. So what is turns out to be x of 1, x of 0 into e power 0. E power 0 is 1, so just write x of 1 plus x of 1 2, here is x of 0 and x of 1, 2 into e power minus minus j pi. So what is the value of e power minus j pi? I have calculated the value of e power pi, which was minus j. So just put the value of that in this one. Similarly, here is 1 into e power minus j 2 pi. This is pi by 2, this is pi, plus 0 into e power minus j 3 pi by 2. I have calculated all these values here. So 1 plus 2, the only difference is negative sign. So at minus 90 degree it is minus 1, minus j. Minus 90 degree minus pi by 2 is equal to 3 pi by 2. So what was the value of exponential at 3 pi by 2? I have calculated that it is minus j. So just substitute this value over there. So at pi, it is minus 1, and similarly it is 0 because 0 is multiplied by this one. So x of 1 turns out to be minus 2j. Similarly, you can calculate x of 2 by substituting the value of k is equal to 2, and in the end you will get the answer equal to 0. So what we conclude that these values will be 4 x of 1 minus 2j x of 2 0 x of 3 is equal to 2j. Substitute the we have seen that how these values came from this formula by using values of k from 0 to 3. Capital N is equal to 4 and small n is equal to 1, 2, 3, 0, 1, 2, 3. So in frequency domain, this signal has fallen. So if we want to see how this signal look like in frequency domain, we have to find the magnitude of this signal. So how we can calculate the magnitude? Just real part square plus imaginary part square. It is 4 for x is equal to 0 mod x of 1 mod is equal to 0. Real part, its real part is 0, imaginary part minus 2a. so it is 2. Similarly, its both part are 0, 0 square plus 0 square is comes out to be 0. Similarly, x of 3, what it comes out to be 0 square plus 2 square is equal to 2. So if we want to plot the magnitude of this signal in frequency domain, it will look like here is 1, 2, 3, 4. So when k is equal to 0, it is 4. The magnitude is 4. This is magnitude and this is k frequency domain. Plot of magnitude in frequency domain. So when k is equal to 1, magnitude is 2. When k is equal to 2, magnitude is 0. When k is equal to 3, magnitude is 3. So here let me tell you another concept, that is Nyquist theorem. So what is Nyquist theorem? Nyquist theorem tells us that if sampling frequency is 2, so what should be the maximum frequency? Maximum frequency should be 1 Hz. Let me explain you with an example. Suppose we have the fs of 8 kHz. So according to Nyquist theorem, f maximum should be f of s divided by 2. It comes out to be 4k. Nyquist theorem tells us that if we want to recover a signal, the sampling frequency should be twice of the maximum frequency in the signal. So let me tell you another example how we can convert a time domain signal into frequency domain. I have the same example, but the only difference is this negative sign. Now I am going to tell you what this sign will affect on our magnitude response of this system signal. So when k is equal to 0, just add this one. You can get k is equal to 0, because when you put 0 over there, exponential will result into 1 and 1 will be multiplied by each amplitude. So just add these amplitudes. What will be the answer? Answer will be 0. And the next step, put k is equal to 1. When we substitute k is equal to 1, x of 1, x of 0, e power minus 2 minus j2 pi 0, k is equal to 1 by 4 plus x of 1 e power minus j 2 pi 1 by 4 plus x of 2 e power j 2 pi 2 1 4 plus x of 3 e power minus j 2 pi n is equal to 2, k is equal to 1. So what will be the answer of this one? Just 1 into 1 plus minus 2 into e power minus j pi by 2, which is minus j. Similarly, this one comes out to be minus 1, 1 into minus 1, because j minus pi is equal to 0, minus 1. So what is this? 0, anything multiplied by 0 is equal to 0. So this turns out to be 1 plus 2j minus 1 plus 0 is equal to 2j. Similarly, you can find x of 2, which turns out to be 4, x of 3, it turns out to be 2j. So what is the difference from the previous one and in this? In the previous we have x of k is equal to 4, 2, 0, 2, and this thing. Now we have x of k is equal to 0, 2j, 4 and 2j. So if we want to find the magnitude of this its magnitude will be 0 square plus 0 square is equal to 0. Similarly, x of 1 is equal to 4, 4 square plus 0 square is equal to 4. This is 2a, sorry. It comes out to be 2 at 2. It is 4. It comes out to be 2. If I want to draw this signal, it will look like similarly when k is equal to 0, its magnitude is 0. When k is equal to 1, its magnitude is 2. When k is equal to 2, its magnitude is 4. When k is equal to 3, its magnitude is 2. So this is k, this is magnitude. So what we conclude from this graph? We have seen that the maximum frequency occurs where the maximum or the largest transition occur. As you can see that it's 1 and the next one is -2. Uh, -2 and the next one is 1. You can see that -1, 1, 0 and 1. There is maximum transition here. So the maximum frequency occurs where there is maximum transition. So this was our today's lecture. Thanks for watching.